ArcSan is now digital.ai. Join us at our booth in the virtual expo hall to learn how our app protection, white box cryptography, and threat analytics solutions can help you stay ahead of the evolving threat landscape.
Hello everyone, and welcome to Don't Worry, Be Happy, which is a terrible pun, but it's all about addressing the modern challenges of API in AppSec. So let's start with a quick pop quiz. What is the common with all these companies you see now on your screen? I'll give you 5 seconds, maybe less. Okay, there are probably a lot of correct answers. The answer I had in mind is that each and every one of these companies exposed some sort of API vulnerability just in the last 6 months. So we can bet that if the big ones are struggling with securing their APIs, the rest of us are doing the same. So we are here to talk about API security. Who am I and what are we doing here? So my name is Erez. I work at Checkmarx as a director of security research. I'm interested in all sorts of all aspects of security, but focusing mainly on application security. I'm a strong believer in spreading security awareness, and very relevant for this session, I'm co-leading the OWASP API security project. One of the superpowers I have in Checkmarx is to be exposed to the thousands and thousands of code bases of our customers and prospects, and mainly to all the broken stuff and mistakes. And it's kind of funny because I noticed that I'm following the technological trends of the market. I'm following them through the trends of security issues. And definitely at the moment, we're seeing everything drifting towards APIs. So what is this API we speak of? I'm pretty sure that all of us knows that API is application programming interface. And I saw the definition in Wikipedia and I liked it. It's an interface or communication protocol between client and server. But I want us to look at it not as the traditional client and server, but every component that is communicating with another component, be it a microservice, an actual client, an actual server, is part of this communication, and every arch between these two components is an API. Who uses APIs and what uses APIs? So we see these days that microservices are definitely using APIs, and everything that is mobile and IoT, B2Bs using APIs, serverless, everything that is cloud is using APIs, and the big trend of single page applications is all about APIs as well. So we love APIs. APIs are great. They give us the time and comfort to actually do other things while the APIs are taking care of the heavy lifting. And basically every modern application these days is built around a beating heart of APIs. So when we talk about API security, what we actually mean is API-based apps security, or in other words, modern app security. Everything that is modern app security is essentially API security. And what is the difference between traditional and modern applications? We have here, side by side, a flow of traditional application and modern application. Let's look at it. So first of all, we have the similarities. Both traditional application and modern application will let the user to interact with the client. I think that the traditional applications, the client were mainly the web clients as we know them. Modern application, it can be anything. It can be a bot, a tablet, a mobile, a different microservice, smart toaster, whatever. And of course, the user will expect to get some sort of response or to get the information or the data they are seeking, and they don't really care what is the technology behind it. Another similar path is the path between the server and the database. Now, in the past, the server was just an actual server, and the database was probably an SQL database. These days, the server can be either an actual server, a bunch of Dockers, something run on Kubernetes, different microservices, whatever. And usually the databases these days are hopefully less SQL and more Elastic and NoSQL. And obviously, the information comes back from the databases to the server. Now comes the interesting part, the difference between traditional and modern application. So while in traditional applications, we saw some sort of GET request go to the server is running some sort of logic, and then returns a fully rendered HTML page to the client, the web client. Now these days, everything is very different. We see the clients sending a set of API GET requests. The server or servers will return raw data, and this raw data will be transformed in the client into the information that the user is looking for. So we see that the logic phase migrated from the server to the client, and with it, a lot of issues. We see also in modern applications that there are less abstraction layers. Both the client and server, and a lot of times the database as well, speak the same JSON language. So everything is very, very flat. So just to mini summarize the differences we just saw. The server is used more as a proxy for the data, not really the logic part. The rendering component is the client, not the server. And the user state is usually maintained and monitored by the client. Also, we can see that clients consume raw data, not a fully rendered page. And more parameters are sent in each HTTP request. We see everything flying through the air, from object IDs and values and filters and whatnot. Also, something we need to think about, and we'll discuss it later, is that APIs expose the underlying implementation of the app. And when you see the API endpoints, you can probably guess what is going on, but we will discuss that a bit later. So what makes APIs vulnerable? First of all, the abundance of API endpoints makes the attack surface much bigger. If in the past, users had to go from A to B to C, maybe even in a monolith stage, and only then they reached the database after they got all the authorization and authentication stages in module A, for example. Now, when you have a microservice, or maybe you can access B directly from H or something else, a hacker can find a way to skip the parts of authorization and authentication and go directly to the data, for example. Another reason is that the clients consume raw data, as we saw, and more parameters are sent in each HTTP request. And it's very, very easy to lose either where this data comes from or where it goes. For example, component 1 here can send some sensitive data to component 2, thinking that everything stays inside the perimeter. But component 1 may not know that component 2 sends some of the information outside component 3, which is public. And also the other way around. Component 1 may trust the information that comes from component 2 without knowing that some of the information on component 2 came from untrusted sources in component 3, which is outside of the perimeter. And the third thing that makes API vulnerable is CI/CD. CI/CD, the flexibility today is amazing. The processes are so effortless, so quickly. Everyone can deploy new microservices and containers and cloud infrastructure in just a click of a button, which is amazing. And the rate of updates and changes in APIs, these days, they just might be too fast to handle. As I said, it takes just a few clicks to spin up a new API host, and you have everything in front of you. So it's not almost too easy, it's actually too easy. And since it's too easy and too fast, we see that APIs become very hard to track. And the result of that is that shadow APIs are created where no one remembers what they do and where they came from. And old APIs are not deprecated correctly and are still exposed. And these things make a lot of areas in your API vulnerable. It's not all bad news, though. I don't want to be a downer. So here are some good news about API. Some traditional vulnerabilities are less common now in API-based apps or modern apps. And here are some examples. We see that SQL injections are dropping, or injections in general. There is an increasing use of frameworks and ORMs that makes this less common. CSRF or CSRF are less common these days because of authorization headers that are used instead of cookies. In general, path manipulations are less common and less severe due to cloud-based storage. Again, it still exists, but it's seriously less severe to have something on a cloud-based storage. And again, it's less common. And in general, many classic IT security issues are being solved slowly but surely by SaaS in general. So as I said, there are some good news. Bridging the gap, when we saw that there is a big gap of knowledge, not only outside, but also within us about how to secure APIs or modern applications, we went to the biggest source we know, which is OWASP. Unfortunately, we could not find any mitigations or any resource that is speaking specifically about API security. And the OWASP top 10, which is great, is mainly, I think, these days handling what we see as the traditional applications. So instead of waiting for someone to bridge the gap, we decided to bridge the gap ourselves, and we created the OWASP API security project. And by we, I mean myself, which I already introduced, and my friend Yinon Shkedi. Yinon Shkedi works in Traceable. He's the head of research there with a lot of years of research and pen testing experience. And in general, he's an API wizard. So he was the best co-leader for this project. When we started, we decided that this project is going to be an umbrella for several relevant projects. We started with the API security top 10, which is already released, and I will discuss that in the next part of this presentation. There is also in progress, some changes are being done into specific sheets in the API security cheat sheet of OWASP. We are already working on that. And the last part of the current last part of the project is going to be Crappy. Crappy is completely ridiculous API. It's an intentionally vulnerable API project, and it's going to be released any day now. So stay tuned. So let's discuss the OWASP API security top 10. This is it. This is the top 10. I'm not going to dig into each and every one of the categories, but I am going to show you the groups that are making this top 10. And we are going to discuss a bit in depth one of the biggest issues, one of the biggest groups. So let's start with the parts you probably know. We have injection and insufficient logging and monitoring. These were borrowed from the regular OWASP top 10. Although injection moved from 1 to the 8th place, we still think it's a thing. But again, as we said, in API security, it's definitely not the top issue. And API 10 is insufficient logging and monitoring. This is obviously very, very important for every application. It doesn't matter if it's traditional or modern. If you don't have logging, you don't know what's happening. And if you don't have monitoring, you don't know what to do if something happens. So that's the first group. The second group is very important, and I'm going to go deeper into it in a bit. This is everything that is about access control. So we see here API 1, broken object level authorization, which is practically who is allowed to touch a specific asset. API 2 is broken authentication, which is all about authenticating the user, understanding who the user is. And API 5 is broken function level authorization. If API 1 is about what the user can access, API 5 is about what the user can do, which functions are allowed for a specific user to do. And access control, obviously, it's very, very important. As we saw earlier this year, the research group in Checkmarks managed to find some access control issues in the APIs of a smart vacuum company. This smart vacuum had a camera feed, and pretty soon we managed to get access to every camera feed that we're using for every user who got this vacuum cleaner, including location and a map of the room. So very important, access control, obviously. Let's move to the next category, the next group. The next group is all that is about access data. API 3, excessive data exposure, is the issue of exposing data to the wrong component or sending it to the wrong places. And mass assignment is actually the other way around, is getting untrusted data and mistaking it as trusted data and using it in your software. A good example, a bit old, but I just like this example, is from, I think, last year. It's a dating application that instead of showing only the specific information that was allowed by a user, kind of sent in the GET and POST requests all the data, including the specific location and specific phone numbers and things like that. This was researched by a researcher named Alex Lomas, and he actually rendered and mapped all the location around the White House, so kind of made a lot of noise back then. And the last group I want to discuss is the group of DevSecOps categories. We have here lack of resources and rate limiting. We have security misconfiguration and improper assets management. Improper asset management is very, very important. This is the problem of running too fast and not being able to know what you have. A lot of you may know it as bill of materials, basically to know what kind of APIs, what kind of endpoints, what exactly you're exposing, and what exactly are you consuming in APIs. Lack of resources and rate limiting, I think we all know that. This, if not protected correctly, we may suffer from denial of service or even brute forcing, which sometimes is worse. And security misconfiguration, API 7, it can be anything. Anything that we have to configure for security and we somehow miss it is a problem. And here's an example from earlier this year. Also, it's from Google Firebase, when common misconfiguration on it allowed unauthorized parties to easily find and access users' personal data in thousands of apps. Again, this is all about misconfiguration. Sometimes just missing one true to false or false to true, or keeping an asterisk somewhere, make everything exposed. Before we go on, I want to talk about access control. This is the biggest challenge in API security. You remember we had API 1, 2, and 5. I want to start with number 2, broken authentication. So broken authentication is all about authenticating, obviously, the user and making sure who they are. And broken authentication happens when we have lack of protection mechanism or misimplementation of that mechanism. So let's see an example of lack of protection. If we have an API set, we know that we want to protect all the endpoints, for example, by rate limiting protection. But you can see that the first 3 here are all about login. We see different kind of logins and password renewal or reset. And for these specific 3 APIs, we want to have an extra layer of protection. And this extra layer of protection can be CAPTCHA, it can be an account lockout mechanism, or some sort of credential stuffing protection. If we don't have that, this is opening us to brute force attacks or credential stuffing attacks. On the other side of broken authentication, we have the misimplementation. Misimplementation can happen because of many issues. For example, we see that developers are using JWT, which is great, but then in the algorithm, they use the word none. Word none means that you just render it useless, the entire JWT. Sometimes we see that services does not validate the OAuth provider, so they are just relying on it without validating it. Sometimes passwords are stored without salt, and this is not good enough, as we know, and many, many other mistakes that bring us to broken authentication. Why is it so common in APIs? I think if we know why it's common, we can probably handle it better. So authentication endpoints are exposed to anyone by design. The software or security engineers have misconceptions. As we said, OAuth, for example, is not authentication, it's authorization. API keys should not be used for users' authentication, and many other misconceptions. Also, there are multiple authentication flows in modern applications. We see different ones in mobiles and IoT and legacy and authentication that comes from the web, not to mention deep links with credentials, etc. There are many, many flows, and it's very easy to forget something somewhere. Let's talk about the next item in access control. That's API 1, BOLA, Broken Object Level Authorization. The scenario, as we know it, is a user trying to access their own document or their own asset. And the system says, OK. And then if this user is trying to access a document that belongs to someone else, that they are not authorized to access, then they get a nope. So if this mechanism breaks and this user can access other assets, then we can say that we have a broken object level authorization, or BOLA for short. And why is it so common in APIs? Remember this, the attack surface is much wider, and we can try to bypass the authorization areas. And also, there is no security solution exists that solves this problem like a silver bullet. It has to be baked into the architecture from day one. What you described is IDOR. I hear some of you cry. And well, we don't call it IDOR. When we wrote the document, we decided that IDOR is not accurate or indicative enough to what we're aiming at here. The D in IDOR says that direct. So IDOR is insecure direct object reference, and IDOR implies that the object reference should be indirect, like using a salt or hash map or random string or whatever added to every ID. We don't believe that the problem here is the reference of the specific object. We think that everyone is allowed to try and touch any object. The lack of authorization here is the problem, is the issue. Also, please, as an exercise for your mind, try to think what would happen if you ask your developers to implement indirect mechanisms in every place that receives ID. Not a pretty sight. And let's go to the third category in this group of access control, the API 5. It's broken function level authorization, or BAFLA. What we call function level authorization is, here's a scenario for an example. We have different admin APIs and different public APIs. Obviously, the admin APIs should be only accessed and executed by admins. For example, an admin would like to delete a specific user. That is okay. That should be possible because this is part of the admin API. If a regular user tries to do that, they should be obviously blocked. They should not be authorized. If they manage to do that, then we say we have BAFLA, or broken function level authorization. Why is it so common in APIs? So function level authorization can be implemented in different ways. It can be implemented in the code itself, in configuration, in API gateway, and there are other methods every day now. I think we all know that if something can be taken care of in many places, it will not be taken care of at all. And we see that happening all the time. Also, it's easier to detect an exploit in APIs because the endpoints are predictable. Let me show you what I mean. Let's talk about a regular endpoint of getting a user profile, for example, and an admin endpoint of deleting a user. How it looked like in traditional software. So in traditional applications, we saw a get, and then something like that, like we see here on the left. And if you wanted to delete a user, you probably had to go to some sort of user management console, choose your action, delete, and do many of these things. These days, with API, the regular endpoint of get user profile looks like we see here on the left, like get API, the version, users, and the admin endpoint of deleting a user looks like we see on the right. Very, very similar. All we're changing here is the get to the verb delete. And the first one, the traditional, is a little bit hard to predict. And in API applications, it's very, very easy to predict. So if it's not safe, someone will find out. Let's summarize. So what you need to remember. What you need to remember is that modern API-based apps are different. You need to remember that being different, they have their own security issues. You also need to remember that the attack surface is much wider than we know it, and there is more data moving between components. And the last thing is that access control is a real challenge. So what you need to do now? What you need to do is to educate. You need to educate yourself, your developers, pen testers, auditors, architects, product managers, whoever. There is no defense against threat you don't know. So educate. Keep an up-to-date API inventory. If you don't know what you have, you cannot protect it. And also try to embed access control best practices from the start, from the get-go. Instead of describing a requirement as a user gets access to their document, try saying it a bit differently. Try to say only that user gets access, read access to their document. This might change some things later in the design. I just want to say that this project was huge. This is not a work of 2 people. This is a work of many people. You can see here many names on the right, dozens of people. And our main contributor who managed to carry both Inon and myself on his back many times, Paulo Silva, our main project contributor. So thank you, Paulo, and thank you everyone else. I suggest that you join us. You can join us in looking at the projects and adding your thoughts and opinions and helping us add more important features to them. So please join us in running and contributing the project. Thank you very much.